Electric machines. Introduction. An electric motor is a device that converts electrical energy into mechanical energy. It works on the principle of electromagnetic induction, where a current carrying conductor generates a magnetic field around it, which in turn interacts with another magnetic field to produce motion. And this is the key concept of the electric motor working principle. Our presentation key points: the types of electric motors, the parts of electric motor principle of working and circuits. For control devices, types of electric motors. Electric motor can be classified into two categories: DC motors and AC motors. Each type of motor has its own unique characteristics and is suited for different types of applications. The first type is DC motors. These motors use direct current power sources and work well for applications that require precise speed control. DC motors are divided into two types: brushed and brushless. Brushed DC motors have a commutator, and the brush commutator convert the direction of current into rotor windings to maintain the power of attraction and repulsion to keep the rotor moving in the same direction. And brushes that collect and conduct current to the rotor, while brushless DC motor use electronic commutation to achieve the same result. AC motors. These motors use alternating current power sources and are commonly used in industry and household applications. AC motors are divided into two types: induction and synchronous. Induction motors are the most common type of AC motor and are known for their reliability and low cost. Synchronous motors are typically used in high performance applications where precise speed control is required. Stepper motors and servo motor. It's two types of DC motors. Let's start with the stepper motor. Stepper motors. These motors are type of DC motors that moves in discrete steps, then a continuous rotational motion. They are used in applications that require precise positioning, such as printers, scanners, and robots. Servo motors. These motors are type of DC motors that can controlled with precision to rotate to rotate to a specific position and hold that position. They are used in robotics and automation systems. The parts of electric motor. An electric motor is made up of several key parts. They are work together to convert electrical energy into mechanical energy. Some of the most important parts of electric motor include stator, rotor, commutator, and the brushes. Stator. The stator is a stationary part of the motor that surrounds the rotor. It's typically made up of a series of coils of wires that are wrapped around a central core. When an electric current is passed through these coils, it creates a magnetic field. Rotor. The rotor is a rotating part of the motor that is located inside the stator. It's typically a permanent magnet or a series of electromagnets that also creates a magnetic field. The rotor is connected to the output shaft of the motor which is what produces the mechanical energy. Commutator. The commutator is a device that used to reverse the current in the rotor windings, which allows the motor to keep running in the same direction. As I mentioned before, it's typically made up of series of copper segments that are insulated from each other and mounted on the rotor shaft. Brushes. The brush is a device that makes contact with commutator, allowing electrical current to flow into rotor. It's typically made up of carbon or graphite and is designed to wear down gradually, so it needs to be replaced periodically due to the friction between it and the commutator. Here is a video graph of representing the motor principle of working and circuit. A motor converts electrical energy into mechanical energy. The basic principle of operation is that a current carrying conductor generates a magnetic field. And when this magnetic field interacts with second magnetic field, a force is exerted on a conductor. This force causes a conductor to rotate, generating mechanical energy. The circuit of motor typically includes a power source, such as a battery or mains power, a switch to control the flow of electricity, and set of coils or windings that generate a magnetic field. The windings are typically arranged in a specific pattern such as a stator, stationary windings, and rotor, rotating windings, to create a desired interaction of magnetic field in order to generate the necessary force to rotate the motor. DC motor and AC motor. DC motor work on the principle of electromagnetic attraction and repulsion between the stator magnetic field and rotor magnetic field, which states that when current carrying conductor is placed in a magnetic field, it experiences a force that causes it to rotate. This force is a force of attraction and repulsion between the two magnetic fields. AC motor work on the principle of electromagnetic induction, which states that the current carrying conductor generates magnetic field, and when this magnetic field interacts with second magnetic field, a force is exerted on the conductor or rotor conductors. The induction motor. The invention of induction motor permanently altered altered the course of human civilization. This motor, invented by great scientist Nikola Tesla, it's the most common motor type even today. In fact, about 50% of global electric power consumption is due to induction motors. Let's get into the working principle of the induction motor. The induction motor has two main parts, stator and rotor. The stator is basically a three coil winding, and the three-phase AC power input is given to winding, passes through the slots of stator, which are made up by stacking thin, highly permeable steel laminations inside a steel or cast iron frame to protect the stator, and made up of laminations to reduce leakage electric magnetic field, stator magnetic field, to reduce the leakage magnetic field of the stator. The generation of the rotating magnetic field. When three-phase current passes through These windings it produce a rotating magnetic field. This RMF is what causes the rotor to turn. To understand how the rotating magnetic field is generated as well as its properties, let's consider a simplified stator winding. Here is three coils. Three coils are connected 120 degrees apart. A wire carrying conductor produces magnetic field around it. When three-phase power is applied to this special arrangement, the magnetic field produced will be as shown. About the creation of motion at particular instant with variation in AC current. A magnetic field takes different orientation as the polarity change. If you compare these three instances, you can see that it's like a magnetic field of uniform strength rotating the rotating rotating rotating. The rotational speed of the magnetic field is known as the synchronous speed. Assume that you putting a closed conductor inside it according to Faraday's law because the magnetic field is varying an EMF will be induced in the loop or in the rotor windings. The EMF will produce a current in the loop, thus the situation has become like a current carrying loop suited in the magnetic field according to Lorentz force law. An electromagnetic force will be produced on the loop, and the loop will start rotating. The same phenomena occur inside an induction motor as well. Control devices. A variable frequency drive is an electronic device that is used to control the speed of induction motor by varying frequency of the power supply. It works by converting incoming power from the utility into direct current. It changes AC current into direct current and then inverting it back to adjustable alternating current AC current to control the speed of the motor. VFDs have several benefits including energy saving, increased torque, better process control, extend equipment life, improve system efficiency. It uh, energy saving by controlling the speed of the motor. VFD can save energy by reducing the power consumption of the motor. Increase torque. VFDs can increase the torque of the motor at low speeds, allowing it to start and stop more smoothly. And we use low speed in applications that require high torque and low speed. Better process control. VFD can provide precise control of the motor speed, which can improve the performance of the process being controlled in industry. Extend equipment life. VFDs can help to extend the life of the motor by reducing the mechanical stress on the motor caused by frequent starting and stopping. Improve the system efficiency. VFD can can improve overall efficiency of the system by reducing energy losses and increasing the performance of the motor. Control devices. The circuit of electric motors typically includes several components such as power source, contactor, overload, motor starter, capacitor, and control circuit. Power source. This is typically source of alternating current such as utility power grid. Contactor. This is an electric switch that is used to turn the motor on and off. Overload relay. This is a protective device that monitors the current flowing through the motor and trip if it exceeds certain level to protect the motor from damage. In case of instant high current due to an effect into the power net from from the generation from the generation planet, it protect our motor from the high current. Motor starter. This is an electronic device that controls the starting and stopping of the motor. It typically includes contactor and overload relay. Capacitor. This is an electrical component that store electrical energy in, in an electric field. It's often used in the circuit to improve the power factor of the motor. Here is an example of basic circuit diagram for three-phase induction motor. We have two types of circuits, power circuit and control circuit. In power circuit, we have a three-phase which is fed to the motor through fuse or circuit breaker. The job of fuse or circuit breaker is to protect our motor from high current, or in case of short circuit, it will protect our motor from high short circuit current. The contactor, which control turning on or off our motor through coil, through its coil in control circuit. Overload, it's protect our circuit also in case of uh, short circuit and high load current. And our three-phase motor, induction motor. In our control circuit, it consists of a lot of parts such as start switch, stop switch, relay or contactor coil, overload, normally a closed contact, and the contactor, normally open contact. When we press our push button, start push button, a current will flow from through a stop switch and reach our relay, which close the normally open contact, and the contactor will be turned on and the power will be fed to our motor. If we pressed our stop push button, the electricity will be cut off the contactor coil. The normally open contact will be open, and the contactor will be open, and the motor will turn off. In case of short circuit or high load current, um, the overload will turn off, and the normally closed overload point will be open and cut off the current in control circuit, and cut off the current from our motor, and turn off our motor in case of short circuit. How to select the circuit components. Determine the full load current of the motor. Select a contactor with a current rating higher than the full load current and that's suitable for the motor voltage and frequency. Choose overload relay with current setting slightly higher than the full load current. ensure that both contactor and overload relay have the necessary voltage and frequency rating for your application. For example, let's say we have a 12 kilowatt three-phase squirrel cage induction motor works on 380 volts, 50 hertz, have output 1450 rpm. The efficiency of motor is 90%, power factor 0.8. According to the relation that power equal root 3 times voltage, current, and power factor, we can calculate from this relation the I load, and from I load we can multiply it in case of contactor by 1.5, in case of overload 1.1, in case of circuit breaker or fuse 1.25, and uh, get our maximum value of amperes, and we will select our contactor depending on our on these values, which is 32 in case of contactor, 25 in case of overload, 30 in case of circuit breaker, and connect our circuit as shown previously. In conclusion, electric motor play a crucial role in powering various industrial and domestic applications. The most widely used type of electric motor is the induction motor due to its simplicity, reliability, and efficiency. Induction motor can be controlled by variable frequency drive, which can adjust the speed and torque of the motor according to the need of the application. With the help of control devices, induction motor can achieve high efficiency, high performance, and high power factor. Understanding the operating principles, design, and the control of induction motor is essential for efficient and reliable operation in wide range of applications. Here is our references, and thank you for listening.